Okay, welcome to the July 28th edition of the study hall. Today's topics, which are taken from previous submissions, for the most part, not the past couple of weeks, are absolute value things, a little bit more. We have had a previous workshop on absolute values. That workshop was dated, let's see, previous workshop on absolute values was dated February 18th. So the stuff that we're going to do today is an add-on. It's some stuff that's not in the February 18th lecture. So check out the February 18th, 2010 lecture for more on absolute values. And the stuff we're going to look at today takes a little bit of a different tack. It's not as basically equations that can't so much be solved with the techniques that are in that study hall. Then we're going to have some unit conversion problems involving converting from one unit to another, like units of volume, money, speed, etc., things like that. And then if time permits, I would imagine that time will probably not permit, but if time permits, then we'll get started on a little bit of mixture problems. A couple of you guys who are here submitted some topics that are going to be considered in future study halls. I see one person here in the audience who submitted some hypothetical rate type stuff, so we'll be doing that later and going from there. All right, in any case, let's go through the usual warnings that we need to always go through, and then we will get started. Okay, the usual warnings about submissions. Please don't submit problems that are too general. Basically, we can't get too ambitious with the scope of the study hall here. You can't submit problems that basically amount to some significant fraction of the entire test all at once. So if you look at the examples that are here on the board, how do I do geometry problems? Not such a meaningful submission. Also, how do I solve problems faster? That could be literally any problem on the whole test. So careful with these things. Also, this is the big one. Please don't submit problems that are too specific. That's what our forums are for. So we have gotten some people asking about one particular problem without really having any sort of theme. And that's the whole purpose of our forums, is to answer specific questions like that. So if you have a specific question like that, please take it to the forum instead of here. Finally, personal issues, scores, study plan, and so on, those don't really belong here. Those belong in the forums as well. And we have 2 folders where you can put questions like that. If it's a question about a study plan and about preparing for the GMAT, then that's the general questions folder on the forum. If your question is more to do with admissions or business schools, then we have an Ask an Admissions Consultant folder. That folder is operated by consultants from MBA Mission, which is a company that we partner with that helps with admission applications. So there you go. Please submit topics that are like this, intermediate depth. For instance, if you have a more general question type like this is good. If you submit a specific problem, please tie it into a more general theme. So, for instance, don't just say I can't decide between C and D on this one question. If that's all you've got, please post it on the forum. But if it's like, can you use some more general type of things, like this type of modifier, or this type of rate problem, or this type of this, or this type of that, then yeah. So don't forget, you need to submit the source of the problem, even if it is from us. If you don't give a source, then we can't use the problem. A couple other warnings that we need to emphasize. No official guide. I know they've updated the submission software so that if you pick official guide, it will just basically tell you, sorry, we can't do that. But nonetheless, some people are still trying to submit problems from the official guide. GMAC has specifically asked us not to do that. So we are going to go ahead and comply with their wishes. So please, no official guide problems. GMAT prep is fine. GMAT prep software from the official people, that's legitimate. Official guide, not so much. For other sources that are not allowed on this study hall, they're the same as the sources that are not allowed on the forum. So for a more complete list of disallowed sources, please consult the general math or general verbal sections on the forum. So there's that. Okay. Any questions about these rules? Smiley face if you understand them and you're ready to keep moving. Smiley face icon, which is over there. Okay, excellent. Let's keep moving. Last thing, as usual, please check the archives before you post. We have had a lot of study halls already, so if you have a topic that has already been covered, please watch the study hall and see if we've covered the aspect of it that you want. So for instance, we're doing absolute values today. We also did absolute values before, but there are some types of absolute value problems that are not really covered by the study hall that we previously did. So the idea is that you should check the archives. If your topic is already listed in the archives, then please watch the study hall that's listed. And then if you still don't see that topic treated, then check it out. Participle and verb forms. That sounds like it was not my study hall. That sounds like it was one of the substitute ones. But all of the back study halls are on the same page. They're just on the front page of Thursdays with Ron. So if it's there, it should be there. It should be on the same front page as everything else. Just scroll down and look for it, or search the page. Okay, so as promised, we're going to do some absolute value stuff. Let's start with that. A quick review of how this works. I'm going to put some polling buttons in your screens. Okay, what you should see below the list of names is the following. You should see this. Again, if you guys are veterans of this study hall, you're already going to know this, but I see a lot of new faces today. New names. I guess I don't see faces. These are polling buttons. When you get an A through E question, please answer A through E questions with these polling buttons. So please do not answer the question in the IM box, because that would be unfair to the people who have not yet finished. So please don't answer in the IM box. Please use the polling buttons. So smiley face, everybody, if you see the polling buttons. Smiley face is here if you don't see it. Okay, so we'll provide you with stopwatches and all that other kind of stuff while you work the problems. So here's the first one. We'll give you a stopwatch. You get a little bit longer for this one, maybe 2.5 if you need it. You may or may not. Go for it. Okay, some of you don't have answers. And again, remember this is the GMAT where you have to answer the problem all the time. So if you don't have an answer, please pick one in the next 10 or 15 seconds. Everybody? Okay, let's see. We still don't have an answer from Nita or Thomas. You guys should pick something. All right, let's check it out. Yeah, Nita, your answer's there. Okay, we're still Thomas Connie doesn't have an answer, and then a couple people who are away. Okay, here's the results of your polling. So it looks like we're split between. Looks like we're split between A and C here. So let's take a look. And while we're at it, we're going to do a review of the two most useful ways to approach data sufficiency. So when you have algebraic data sufficiency problems, two most useful ways, or the two primary ways, to approach algebraic data sufficiency. The first way to approach is to use algebra, if you know how to do it, or if you know how to use some sort of theory. Second is what? Does anybody know? Text box? Does anybody know how else you can approach these things? Yeah, you can plug numbers. So we'll get to the algebra here in a second, but let's make sure that we know how this works. So again, we'll talk about the algebra in a little bit. So next slide, we'll do that. But let's talk about plugging. So let's just do a quick review. It's already been covered once, but it's important enough that it's definitely worth covering again. So plugging has been treated in the February 4th, 2010 study hall, but it's definitely worth treating again. So let's check this out. What do you guys think as far as plugging numbers on a data sufficiency problem? Go ahead and answer this in the IM box. In the IM box, when you plug numbers for data sufficiency, do you need to plug multiple possibilities or just one possibility? What do you guys think? Multiple or one? Yeah, it looks like you guys definitely have this one. You need multiple possibilities, and let's talk about why. The way to, I mean, for some problems it's negative and positive, like this problem, yeah, for sure. But for other problems, it's basically just a whole bunch of different possibilities. So when you approach data sufficiency with plugging, the deal is that you need to plug in multiple diverse possibilities. So I mean, diverse can mean different things from problem to problem. Like in a problem like this, diverse is pretty much going to mean positives and negatives and zero. In other problems, diverse is going to mean other things. Then, what does, if you're plugging in a bunch of possibilities, then what would sufficient mean? Sufficient would mean that what happened. Go ahead and indicate that in the text box. Sufficient means that you plug in a whole ton of possibilities, and what happens? Means you get the same answer every single time. So sufficient, if you get the same answer to the prompt question every time, then you put sufficient. And if you get different answers, if you ever get two different answers to the prompt question, then you can immediately say insufficient and you can immediately stop. So, all right, let's try this for statement 1. In this problem, actually, statement 2 is probably a little bit easier. Statement 2 is just x is less than 0. So that's not going to be sufficient. But let's prove this with plugging. I mean, this isn't going to be sufficient because you definitely need y and z to figure this out. But plugging, if you let x is 0, y is 0, and z is 0, then that's a yes to the question. And if you let them be basically like anything else, unless you get really unlucky, it'll be no. So like if x is, 29 and y is like 2 and z is like 10, then that's a no. Those are just random numbers. So that means that statement 2 is insufficient. Okay, smiley face if this makes sense. Okay, and remember when we're talking about this is a yes-no question in this case. That means that answers to the question are yes and no. So insufficient amounts to getting a yes in one case and getting a no in another case. And now statement 1 was where people were not really sure here. So, and what I want you guys to see is that if you do plugging on statement 1, you can get rid of statement 1 very easily. So let's do plugging. X plus y equals z. So x, y, and z we need to pick. And then yes or no to the question. So someone give me an x, y, and z such that x plus y is z. Someone just like spit one into the text box. Okay, how about 1, 2, and 3? 2, 3, and 5. Okay, 1, 2, and 3, so that works. So if we plug in those values, then the question becomes, is 1, absolute 1, equal to 3, equal to 2 minus 3? This is no. So a couple people have said 3, 2, and 5, so let's try those. So the question there becomes, is absolute 3 equal to 2 minus 5? That's also a no. Then what else, what other kind of number should we be trying here, especially for x? We should be trying, we should be trying negatives. Or we can try 0. Yeah, that works too. So 0 is a good idea. So then you get is absolute 0 equal to 0 minus 0. That's a yes, so we've got insufficient. So people who thought that A was sufficient, which is a lot of you guys, notice how easy it is to prove that that's not true by plugging. So if you don't have plugging in your toolbox, then it should be there. You need to start using it. So this is insufficient. Also, if you try negatives for x, I mean, you don't have to at this point because you're done. I mean, you proved that it was insufficient. But if you try some negative value for x, -1, -2, -3, then you get is absolute value -1 equals y minus z be -2 plus 3. So that would also be a yes. So if you didn't plug in zeros, then that would also prove insufficient. So smiley face if you understand that this is proof of insufficiency. And I'm especially looking for smiley faces from people who picked A. So, okay. Yeah, the smiley face, you don't have to put it in the text box. The smiley face icon is over there on the left-hand side of your window over there. So now let's do together. So let's take the same problem. We're down to C versus E. So we can still do plugging. Plugging for C versus E, we need to satisfy both statements. In other words, what we need to do is pick numbers such that x is negative and also x plus y equals z. So let's pick some of those. X, y, z, and then absolute x equals y minus z. So yes or no. So okay, well we can take this set from last time. We can take the last plugin that we did still works. So we can keep those. That's a yes. Let's just try a whole bunch more numbers. So let's plug in some more. Let's say x is, negative 10 and y is nothing and z is also negative 10. So that means that an absolute negative 10 is supposed to be 0 plus 10. That's a yes. The question in the text box says, so if 3 variables, you have to pick all 3. What you have to do is you have to pick things that make the statement true. So it doesn't matter whether you view it as picking 3 or as picking 2 and finding the third one. Those are still the same. So like if you, I'm not picking these independently. That's important for you to realize. Like I can't let x, y, and z be like, negative 1, negative 2, and 50. Because if I did, then statement 1 would be false. So, you can look at it as one of two ways. You can either look at it as picking a set of 3 numbers that does this, or you can look at it as picking 2 of these numbers and just finding the third one, which might be what you're asking me in the text box. But those are the same. Like as long as you get 3 numbers that satisfy this, you're all good. So, okay. Let's see. Other x's, you can also try like negative 10 and then 10 and 0. So does negative 10 absolute equal 10 plus 0? That's also yes. Let's try. So we're trying to get all the possibilities here of these different things, positives, negatives, and so on. What if we had like negative 5 and like 100 and like 95? So is the absolute value of negative 5 equal to 100 minus 95? So that would be a yes. And in all of these cases, basically you should keep plugging until you don't really have a lot of time anymore. So if you keep plugging, you'll notice that you get yes every single time. Unless you pick numbers wrong. Like if you get a no to this, then something is not right about the numbers that you picked. Like either x is not negative or this is false. So after a while you say, okay, I give up, sufficient. So C. That's the plugging method. Notice that the plugging method requires no algebra at all. And a couple of statements about a couple of facts about the plugging method. One thing you can tell is that it usually requires little or no algebra. In this case, it requires no algebra at all. But more importantly, lots of problems that are hard with algebra, or even impossible with algebra, are easy with plugging. It's also true the other way around. There are lots of problems that are hard with plugging that are easy with algebra. So, if you try fractions, then, fractions don't matter in cases like this. Like, there's nothing, these properties of numbers don't deal with fractions. Like absolute values and things like this, they don't have to do with whether the numbers are fractional. So you can, try them. You won't get anything different. My main point here is number 2. Like, the test is designed, like, one really important point about this test is that the test is designed from, like, start to finish so that a diversity of approaches will be much more successful than anything else. So in other words, the test is designed so that if you just approach it with algebra all the time, you will not do that great. The test is also designed so that if you just approach it with plugging all the time, you won't do very well either. But if you approach the test with a mixture of strategies and you can go back and forth between them, then you will find that you'll get your best result that way. So keep this in mind. By the way, another Thursday study hall reference. There's a session on November 4th, 2010. You may want to check that out. That's a session on problems where, in fact, algebra is actually impossible. So let me notate that here. In fact, algebra is actually impossible on many problems. See the November 4th, 2010 study hall for some of these. Pablo asks, are there any clues to know if plugging is easier than algebra? Not really. But that's kind of the wrong way to be thinking about this. So let me post this question. We'll do the algebra to this in a second. It's good to address this because there's a very strong point about the mentality with which you should approach this test. This question suggests a mentality of, I'm going to exaggerate a little bit here. I mean, this is not, necessarily this extreme. But the mentality behind a question like this is I have to figure out exactly what will work before I try it. Okay, that is a very bad way to approach this test. Okay, especially because you have this time constraint that you have. I mean, you can't sit there like a chess master and be like, I need to think through, 6 moves ahead of time. It's not like that. Remember, guys, you have like 2 minutes on average to solve these problems. So if you are in this mindset where you have to figure out exactly what will work before you set pen to paper, you can be in trouble. So what you should do, honestly, is just this. Is just try something. If it's not working for you, then quit immediately and try something else. I mean, this is it. This is not, as you can see, this is not exactly what you would call a genius strategy. I mean, there's nothing terribly complicated about this. But for a lot of people, this is a massive change of mindset. Because a lot of people approach this test with this very sort of perfectionistic point of view, where, like, I have to figure out everything before I dive into it. Well, guys, no. And part of the reason is that this test, think about what this test is designed for. This test is designed for future managers of businesses. And, business is not like that. Like, there is never, ever, ever a business situation where you can think everything out ahead of time and then go into it. You can't do it. Like, business is all about, let's just dive into this and see what happens. And if it's not working, let's adjust. So, they've created a test that basically mimics that kind of mentality, and that's the reason why they have done that. So, you shouldn't really be obsessed with looking for clues. You should just do things, and then if the things you are doing are not working, then you just do something else. Okay. Let's try looking at the algebra for this problem. So we know the answer is C, but let's forget that for a second and treat it new. Okay, algebra solution. So, what we should probably do with this is, if we're going to approach this with algebra, let's try to translate, so to speak. So what does that mean? Can anybody break that down in the text box? Okay, a few of you guys have started to break this down in the text box. Let's take a look. Some people are not being specific enough. In fact, most people are not being specific enough. Like, what you can't do is just something like this. What you can't do this that I put on the board here, because this is not specific enough. Like, you're not enumerating the cases in which these things happen. So, I mean, you might have done more reasoning on your own paper, but like, this is not specific enough because it doesn't enumerate when you use which one of these. Because these equations are not randomly both valid. Like it's not this kind of situation where as long as either of these things is true, then you're good to go. I mean, it's a very, very specific sort of deal. So, okay. Remember what an absolute value is. What is an absolute value? Well, an absolute value does the following. An absolute value reverses the quantity if the quantity is negative, doesn't reverse the quantity if the quantity is non-negative. That's what an absolute value does. So let's take a look at the result of this. And and in fact, what you can do is you can revise this a little bit. It's actually, if the quantity is 0, then you get basically either of these possibilities. Because 0, if you reverse it or don't reverse it, it doesn't really matter. It's the same. So, but reverses the quantity if the quantity is 0 or less, and doesn't reverse it if it's 0 or more. So let's take a look at what this means. Absolute value x equals y minus z. This means if x is negative, then you have to reverse the x, because x gets reversed. In fact, if x is negative or 0, so if x is less than or equal to 0, and then if x is greater than or equal to 0, then it doesn't get reversed. So you just have the regular equation. Notice that, I mean, the case where x is 0 is double represented here, but those are the same. Like if x is 0, then actually both of these are true, because negative 0 and positive 0 are the same. So that's what this means. So we can rearrange these things so they look a little bit more like statement 1. But if you if you move things around so that everything is positive, then this statement here becomes z equals y plus x. This statement here becomes x plus z equals y. We're just doing basic algebra there. So let me show the steps that I'm doing. We are, in the first case, we're adding x to both sides. And then also plus z. In the second case, we're adding z to both sides. So notice that this looks like statement 1, but only in one of these two cases. So if you look at statement 1, if you have this case where x is less than or equal to 0, then statement 1 will work. So if x is less than or equal to 0, then this statement is sufficient, or this statement is a yes. Because if you look here, then there's your proof. On the other hand, if x is not greater than or equal to 0, or if x is not less than or equal to 0, if it's greater than or equal to 0, then you don't know. Because this is a different equation. So that's why this is insufficient. The takeaway that you need to get from this is when you split an absolute value, you must keep in mind when each part of the split is true. In other words, you have to impose conditions on this. It can't just be this or this. It has to be this specifically when x is in this range, and this specifically when x is in that range. Smiley face if this stuff makes sense. If it doesn't make sense, questions, you gotta put them in the text box. Okay. Statement 2, definitely not going to be sufficient. Because this doesn't tell us anything. I mean, we need the values of y and z. But if you have them together, then you know that you are dealing with this case right here. Just the case where it's a yes. So that's going to be sufficient. So notice there's a bunch of things I want you to notice about this problem. The first is, of course, how to process these absolute values. I mean, you do have to know how to do this kind of thing. But it would be a mistake to focus all of your energies on just doing that, because, frankly, what is just as important as that is learning to do this plugging. I mean, because, you know, this plugging, especially dealing with statement 1 by itself, this is not easy to do. Like dividing this into these two statements and all this other kind of stuff. Yes, you should know how to do this, but notice this is a royal pain. It's really not easy at all to do this. Versus this handling of statement 1 is very, very, very easy. You just pick a couple sets of numbers and throw them in there and, oh, look, insufficient. So basically what I want you to realize is this. Algebraic approaches versus plugging. Okay, the first point, the most important point, is that you need both. Okay, you cannot rely on just one or the other. What I mean by you need both is that on some problems, algebra is impossible and plugging is required. On some problems, plugging is impossible and algebra is required. So also, I spelled problems wrong. Okay. Also, the deal is this. Like, when statements are insufficient, plugging is generally easier. When statements are sufficient, algebra is generally easier. And there's really no way to tell. There's no reliable way to tell ahead of time which one of these is going to be the case. So again, remember what we said before, just try something and be willing to switch quickly if the thing you're trying is unsuccessful. Majorly important points. I mean, what I mean by this is when statements are insufficient, plugging is easier. Notice what I mean by that. Because I mean, with algebra, insufficient statements are generally this horrible pain in the neck. Because what happens is nothing happens at all. Like when you're dealing with an insufficient statement, what that means is you just do a bunch of algebra and nothing much happens. You know, you just keep pushing things around and we don't know. Versus in plugging, you actually get two hard answers that contradict each other, and it sometimes happens very quickly. So if you're doing algebra and getting nowhere, you need to be willing to switch very quickly to plugging. Okay, questions about any of this or about the preceding problem? If you have them, type them in the text box. If not, we'll look at another. Okay, doesn't look like anybody has questions. So here's another problem. I'll give you, this one's from GMAT Prep, I'll give you a timer again and have fun. Okay. Let's take a look at this. Some of you still don't have answers. We are waiting on Thomas and Vinci. Thomas Carney. No answer. Okay, I think Thomas might not be here because he didn't answer the last problem either. So, okay, here are your polling answers. Interestingly, there's actually one correct answer to this problem, so now you know at least it's one of A and B. And interestingly, there were no correct answers until the very last person who answered. So, interesting. That might mean that that was a guess, because if you waited until 2.5 minutes, then maybe. But let's take a look. Okay, if y is greater than or equal to 0, what is the value of x? So this problem's a little bit different. If you try to approach this problem with algebra straight up the old school way, it's not very easy. But let's take a look at statement 1. Let's use plugging. Okay, statement 1. Absolute value x minus 3 is at least as big as y. And we're looking for x. Okay, somebody give me some x and y that make this work. And again, first of all, before you even do that, let's make sure that we know what we're looking for here. What would sufficient mean on this problem, and what would insufficient mean on this problem? Text box, please. Sufficient means what? And insufficient means what? Yeah, sufficient means only one possibility for X. We don't care about Y. Insufficient means two or more possible values for X. So when you plug, what's important to realize here is what you're trying to do. So when you plug, you're looking at values of X. And so what that means is that that's your goal. Your goal is to try to get different values for X. So when you're doing algebra, it's a little bit different, but when you're doing with plugging, your goal is to try to get two or more values for X. And if you can't, then you give up and say sufficient. So goal, try to find two or more values for X. And then if you ever find two or more X's, then stop, and it's insufficient. But if you keep getting the same, if you can't find more than one X, then give up, so sufficient. Okay. So statement one, if you understand this, by the way, do not approach problems until you understand what you're doing. This is one thing where people have a lot of trouble in data sufficiency because they don't do that. They don't actually take the time to figure out what they're doing before they do it. So you can see how that would be an issue. So statement one, if we can get X to have two or more values here, then that's insufficient. So let's try that. Let's X, Y, and then there's nothing else to do there if we get two or more X's. So, okay, if we just let Y be like 0, then any X at all will work. So if X is like 5 and Y is 5, well, let's try random numbers. If X is 5 and Y is like 1, then that works. But if X is also like 10,000 and Y is 1, then that also works. So that's insufficient. Let's do statement 2. Absolute value of X minus 3 is less than or equal to negative Y. Can somebody give me an X and a Y that make this true? Text box, please. So some of you guys are giving me 3 and 0, because that works, right? And that means that this works because absolute 3 minus 3 is less than or equal to 0. 0 and 3 doesn't work, because then that would be saying that that 3 is less than negative 3. Someone's saying negative 4 and negative 2. Let's try that. This would give is absolute value of negative 7 less than or equal to positive 2. This is false. So that doesn't work, because that makes the statement false. Oh, yeah, and you're not allowed to do this anyway. That's a good point, because Y has to be not negative. So this is not allowed, because Y can't be negative. So we just cross that out and pretend it never happened. So because there's a condition in here that says that Y has to be positive or 0. Can you guys come up with anything else? You can't, right? You can't find any other plugs. You won't be able to find any other possibilities. So, sufficient. So, well, what you have to do is you have to pick numbers that make the statement. Claire says, can we just pick any value for y without paying attention to the -3? Like, when you're picking numbers, you have to make the statement true. That's the point here. So we have to make this actually true. And if you play around with subject to this condition. So if you play around with numbers for long enough, this is what you'll find. You'll find that the only possibility that works here is 3 and 0. Because if you try y is anything other than 0, like if y is anything, any positive number, because y can't be negative. If y is any positive number, then you get absolute x minus 3 has to be less than or equal to a negative, which is not possible. And I mean, the point here is that you can discover this by plugging. Like if you try to plug in any y except for 0 here, you will soon notice what happens. Like if y is 1, then you have an absolute value less than -1, and that can't happen. If y is like 2, then you have an absolute value that's less than -2. That can't happen either. So the other point about plugging is that plugging allows you to discover patterns or facts that you wouldn't otherwise have been able to figure out. Because, I mean, from the results of the polling here, it's clear that you guys didn't really figure this out. But if you look at plugging, the plugging will figure it out for you, because you just won't be able to come up with anything else. And after a while, you'll be like, oh, hey, I see what's going on here. Whenever I plug in a positive for y, I get a negative on this side, and that this is not ever going to happen. So, smiley face if you guys understand this. Okay, so yeah, that works. And then why is this sufficient? This is sufficient because x has to be 3. Like this is literally the only possibility. And so that means that x is definitely 3. All right, other questions, if you have them, type them in the text box. So the main point here being this. Don't be afraid to start plugging. Not only because plugging is effective, but also because like plugging will totally help you to discover things that you didn't figure out. JC, how long have you been here? Because the question is this preferred over using math? And I've addressed that 2 or 3 times. So if you were late, basically the answer to that is this. I mean, there's no preference. You need both approaches, and trying to think about preferences will just hurt you. You want as many ways as you can to approach these things. You really don't ever want to think about which one is better or preferred. Because in practice, what that means, if you decide that some approach is preferred, then what that will mean in practice is that you will just never use the other approach. And that's bad. Like you'll wind up with a situation where you leave the other approach on the shelf, and you don't ever use it. So they're both preferred. And in some cases you will need one, and in some cases you will need the other. It doesn't really matter which one you try first. If it's not working for you, then just quit. It's basically the deal. Definitely worth repeating a number of times. All right, other questions about this problem? Okay, there don't seem to be questions. Try this one. I'll give you about 2.5, 245 again. Okay, go for it. I'll clear out your answers. Have fun. All right, guys. There's still a lot of blank answers to this, so let's get something. Take another 10 or 15 seconds. Okay, everybody pick something. All right, let's see. Still waiting on the usual suspects here. All right, let's go for it. This is a slightly modified version of a GMAT prep problem. It's not the exact GMAT prep. It's modified a little bit. Okay, here are your answers. Okay. So there you go. Let's take a look. Yet another way to interpret absolute value here. But let's talk about where we might go with this first. Does anybody know, let's see, is absolute value A minus C plus absolute value A equal to absolute value C? You could theoretically do this with algebra. We'll come back to that if there's time here. Or you could theoretically do plugging. Or you could theoretically use a number line interpretation. So let's talk about this first. Okay. Number line interpretation. What does absolute value mean on a number line? Text box if you know. It means distance. So number line interpretation means absolute value is distance. There's two different kinds of distance that you can get out of absolute values. The first kind of distance that you can get is distance from 0. So if you have absolute value of a single number, that's distance from 0. For instance, if you have absolute value of A, this is the distance between 0 and A. On the other hand, what's the absolute value of a difference? Anybody know? It's not the difference of the two absolute values. It's not really the distance from a center either. Yeah, it's just the difference between the two values. So distance between the two values. So, for instance, this is a new fact to make sure that you retain it, but for instance, the absolute value of A minus B is the distance between A and B. So you don't want to think about it as the distance between A minus B and 0. That would be sort of weird. But you think about it as the distance between A and B. So also, I mean, if you had something like this, absolute value of A plus B, that would be the distance between A and negative B. Because that's A minus negative B. But that's the two things you need to know. Absolute value of a difference is the distance between two values. And absolute value of a single number is the distance from 0. So let's keep these things in mind when we interpret these things. Statement 2, let's use, that's a little bit easier because there's no mention of C. What does AB less than 0 mean? Yeah, it means that you have different signs. It means that one of them is positive, one of them is negative. So, no, one of them is not, it means not 0. It means that, because it's an inequality. If you had AB equals 0, that's what it would be. One is positive, other is negative. And also, we don't know anything about C. So let's just try drawing some number lines. Let's say that we had, I'll tell you what, it'd be faster to draw it this way. One way for this to happen is to have like A be here, and then C, and then 0, and then B, as long as one of A and B is positive and negative. So I'm going to color code this accordingly. The difference between A and C, that's this. The distance between A and C. This is just the distance between A and 0. And then this is the distance between C and 0. So let's mark those on this number line. A to C distance, that's this one. A distance is this one. And C distance is this one. So remember that yellow plus green is supposed to be red. So that's definitely not true here. So now what we need to do is try to make it true. So if we put C farther out than A, because remember C can go literally anywhere, then it'll work. So here the difference between A and C is here. The distance between A and 0 is here. And the distance between C and 0 is here. So yellow plus green equals red. Here, yes. So this is insufficient. Any questions? Okay, let's try statement 1. So, statement 1 means AB is greater than BC. So what we can do is we can divide this by B, but make sure that you are very, very careful when you do that, because you do have to think about what happens. Notice that B, so we can divide by B because we know that B is not 0. Does anybody know why do we know B is not 0? B does not have to be positive, but yeah, exactly, the inequality. I mean, like if B were 0, then this statement, then the statement AB greater than BC would be false. So yeah. So what this means is there's two cases. It means either B is greater than 0. If B is greater than 0, then the alligator wouldn't flip. Or if it's negative, then you have to flip. So we just need to make number lines for that. So yeah, you have to, in the case that B is negative, you have to flip. So you just have to divide it into 2 cases accordingly. So let's try these. Let's try B is positive and A is greater than C first. Notice in this case, we don't care about B because B is not related to this question. So unless B is actually involved in this inequality, it just doesn't matter because the equation only involves A and C. So I mean, I'm not crossing it out so much as we're just saying this doesn't matter because B is not in the question. So we don't have to think about this because B is not in the prompt. So let's try that first. If we try that first, then A is somewhere greater than C. So like if we do, we can try them both positive. And then B is somewhere over here, and we just don't care. It doesn't make any difference. So the things in the equation are the distance between A and C, the distance between 0 and A, and the distance between 0 and C. Oh, A is not greater than C. That's bad. So C here, A here. So these are all different. Oops. Let's try that from scratch. I mean to delete that. Okay, so we have 0, and then we have C less than A. So then our yellow line is the difference between A and C. That's here. Our green line is all of this. And our red line is here. This would be a no to the question. Because yellow plus red does not equal, yellow plus green definitely doesn't equal red here. But then we can put C to the left of 0. Or we could put them both to the left of 0. As long as A is bigger. So in this case, your yellow line is here, your green line is here, and your red line is here. This is still no. But then here, your yellow line's here. Your green line's here. And your red line is here. So that's a yes. So this is still insufficient. Questions? If you have them, type in the text box. Now let's do these things together. Let's put them together. So it's statements together. If we have the two statements together, what we can do is we can combine them to make BC is less than AB, which is less than 0. So we can divide all of this by B. We still have to worry about the same sign issues that we had before. So this means one of two things. This means either B is positive, and then we leave those signs the same. So C less than A less than 0. Or we flip. So, all right, let's try these. So if B is positive and this is true, that's C, A, 0, B. That's the only order these things can come in. So that means yellow is here, green is here, and red is here. That's a yes to the question. The only other case is B negative and all the signs are backwards. The alligators are backwards. So B, 0, A, C. This is just a mirror image of the existing one. If you recognize that, you don't have to do anything. But if not, you can just find your lines, again, the normal way. That's the green line. This is the red line. And then this is the yellow line. So this is still a yes. It's actually the mirror image of the last one. So this is sufficient. So questions about this number line approach. I mean, it takes me a while because I have to draw this all in Illuminate, which is not fast. I mean, if you do this on paper, you can definitely do it a lot faster. Questions about this approach, if you have them, put them in the IM box. Okay. Doesn't seem like anyone's typing. All right. If there are questions, we'll grab them in a second. So we'll look at algebra here in a sec. Plugging, the idea is that I want you to try this on your own. You should find that with statement 1, you can find numbers that give yes and no. With statement 2, you can find numbers that give both yes and no. But then when you combine them, you get yes for every single group of numbers that you plug. So that's what you should find. Algebra-wise, it's really not fun, but you can do it. What you have to do if you want to do algebra here is you actually have to split the question into 4 cases. So the first case is A is less than or equal to 0, and B, and you have to split it up according to the signs of A and C, which is really, I'll give you the basic outline for how this works without having to spend too much time. The first case that you have to consider is this and this. The second case you have to consider is this and this. Sorry, it takes some time to type in greater than or less than or equal to signs. The third case is this. And the last case is where they're both negative or 0. So fourth case, this. Robo SC9 says that when I plug in, I often get confused as to whether to use fractions or not. Again, same thing I told the other student about you're trying to think too much. If you don't know whether to try fractions or not, just try fractions. It can't hurt you. Because, I mean, you know, if it turns out that fractions are unnecessary, then what will happen is just you'll get the same results that you get for other things. So, if you are wondering whether to try some type of number, just try the numbers and just watch what falls out. I mean, if they turn out to be unnecessary, it still doesn't hurt you. So, I mean, okay, needless to say, these are not exactly what I would call fun. So, and then, yeah, you also have to, yeah, that's true. You also have to, here you would need 2 cases corresponding to whether the absolute value of A bigger or smaller than C, because this difference would be affected by that. And then here you would also need the same 2 cases. So in other words, you would need 6 cases. And I mean, I won't explain where all of these come from because, you know, really guys, but I'll show you what you'll get in each case. Like in case 1, if they're both positive, you'll get, actually wait, no, you need 2 cases there too. You don't need two cases here. You need the cases here and you need them here. So if you have, this is not fun, absolute value A is greater than absolute value C, then you get is A minus C plus A equal to C, question mark. So that's, that looks like a yeah, that looks like a no, not necessarily. If that's the other way around, then you get is C minus A plus A equals C. That's a yes. Here, if A is positive and C is negative, then that difference is positive, so you get is A minus C plus, that would be A equals negative C. So that's a not necessarily. Here you would get the other way around. This would be C minus A plus negative A equals C. That's not necessarily. And then here again, if A absolute value A is bigger, then you get is if these are negative, then that means C minus A plus negative A equals negative C. That's not necessarily. And then if it's the other way around, then you get is A minus C plus negative A equals negative C. And that's a yes. So, I mean, okay, needless to say, this is not fun. I mean, I don't really want to get into explaining why these cases are what they are. Someone wrote in the text box this. Let's see if you guys have been paying attention to this study hall. Let's see if anybody knows how I'm going to answer this question. Text box if you know what answer I'm going to give to this. Yeah, okay, you guys have been paying attention. Good. Don't think this stuff out ahead of time. Just try something. And then, if it doesn't work, then move on. So, I mean, basically, if you try doing algebra on this, you would very soon realize that this would have to happen. Because you can't simplify this question without knowing certain facts about the signs of A and C. So, I mean, it's not, even if it's not necessarily an instant realization, you would still be like, look, dude, I would have to break this up into like 6 cases. And, I mean, there's also your own skill set. Like, if you can do this fast enough, then you might just want to go ahead and do it. Because there definitely are people out there who can do this in 2 minutes. I mean, those people are not me. I definitely can't do this in 2 minutes. But, you know, the point is just to try stuff. So, the absolute value questions, there you go. Let's try something, move on. As far as absolute value stuff, there's no other major ways that I know of besides the number line interpretation and plugging and theory. I mean, there's other things that you can do that fall under the umbrella of theory. But, yeah. Anyway, let's do one more, and we'll do a really, really fast explanation of it, and then we'll get out of here. So, try this. Go for it. All right, everybody pick something. Next 10 seconds or so. Okay, still waiting on a couple people. All right, here, let's go through this quickly because we do have to finish here in a couple of minutes. Here's the answers. The majority answer here indeed is the correct one. Let's talk about this expression. Okay, so does anybody know what's going on with that green box? Text box if you know. Yeah, basically, if you investigate this, well, you know, let's investigate with plugging. Like, if we don't know, let's just plug. So let's do statement 1. X cubed is less than X. Does anybody know where that happens without having to do a bunch of algebra? Where is the cube less than X? This happens for, you guys are mostly getting half of it. You're either saying negative or fraction, but it's not either one of those. You have to think about both. This happens in 2 cases. The first case where it happens is positive numbers between 0 and 1, because those are the ones where if you raise them to the third, then they get smaller. But it also happens for negative numbers less than negative 1. Like, so, you know, negative 2. Because then when you cube those just get more negative. So, let's see. Let's try a bunch of these. So let's try a bunch of positive numbers between 0, like a half, and then maybe 0.001, and then maybe 0.99999. And then also let's try like negative 1.001. Let's try like negative 5, and then like negative 10,000. And if it works out the same way, we'll trust that it works out. So this is 0.5 over 0.5. This is point that over that is 1. This is that over that, which is 1. This is plus that over negative that. So that's negative 1. This is plus 5 over negative 5 equals negative 1. And this is plus that over negative that again. So notice what happens. Again, plugging allows you to discover things that you would not otherwise discover. And sometimes you can discover them really fast. So again, plugging allows you to discover things. So this expression is just 1 whenever it's positive and negative 1 whenever it's positive. But if you check whether these things are less, yes, that's less. So's that, so's that, so's that, so's that, and so's that. And all numbers between 0 and 1 are less than 1. Also, all negatives less than negative 1 are less than negative 1. So yes, always, and you get sufficient. So this is basically the theory. But if you do the plugging, then you can discover the theory. It's kind of neat. Let's do the other case, and then we'll finish. So statement 2, which is x squared is greater than x. So that also happens in 2 cases. It happens in the case of fractions between positive numbers between 0 and 1 again. Sorry, positive numbers greater than 1. and then all negative numbers. Because if you have a negative number, then x squared is positive, so it'll be bigger. So let's try some of these. Let's try 1.01. Let's try 5. Let's try 10,000. If you can't hear, check your audio setup, because I have no power to adjust your audio. Let's see. Let me type that to that person. If you can't hear, go to... oops. Okay. Text box. Sorry about the delay there, guys. Okay. And then we need to try negatives. So let's try like negative 0.5. Let's try like negative 1. Let's try like negative 10. Okay. So if you remember what happened last time, then we know what all of these are going to be. All these negative absolute x over x's. These are all going to be 1. And then these are all going to be negative 1. Yeah, if you hear the hyper voice, that means your sound is getting caught back up. So, okay. So are these things less? Well, these are not. And this is not, but this is yes, it is. So this is insufficient. It's supposed to say yes, not yet. Alright, so, ladies and gentlemen, the statement is insufficient, and so your answer is A. Okay. Questions? If you have them, type them quickly. We're going to close up shop here in about a minute. So, good times. It looks like we didn't get to do any unit conversions either, so we'll do those next time as well. I don't think anybody's typing questions. So these items we will do next time. So also I will try to do some of those rate problems, because I know that one of the submitters is on a deadline or whatever. So next time with more hypothetical RTD problems. Okay, so those will go to next time. Today's study hall wound up just being absolute values. And, all right. Sid says, I'm going to close the sound here. Let's see. Maybe I'll read the sound while I answer this. Sid says, if you see multiplication, then trying a number line will be difficult. Well, Sid, all you have to do in that case is just try it. I mean, if you try a number line approach and you find that it's unworkable, you just quit. I mean, again, it's always better to reject something after trying it than to just kind of sit there and wonder, you know, whether it'll work. Because, I mean, again, rejecting things like that will really not take very long. So, you know, if you're not sure, just give it a shot and see if anything works. Okay, if you guys have any admin type questions, business related questions, etc., go ahead and fire away. Otherwise, we will do it in 2 weeks. Yeah, exactly. Dive in and just try to swim through it. Okay, I'm going to kill the sound, and I'm going to log you guys out in about a minute. So I will see you in 2 weeks, and have a good one.